Hello everyone. Today I'll cover the topic that car aerodynamics. What the aerodynamics is initially, what the aerodynamics is and why it is important for a car. So nowadays that car is not that thing which, not only that thing, I must say that not only that thing which is used to go from one place to another place, just like a bullock cart. Now a passenger needs a safe environment and also that comfort, and the comfort not only in the sense of that sitting there in that car, but also he or she don't want to listen so much noise. And what the passenger or car rider wants, that in the cabin of car, the less and less sound should be there, whereas the efficiency of car should be better, and that noise should be minimum. And for that aerodynamics is important. Initially that aerodynamics deals only with aeroplanes, but nowadays it is much more important for a car manufacturer. That car manufacturer should think about the aerodynamics of car, and when he or she think about that aerodynamics of car, that car definitely will make happy that owner of the car. So the car aerodynamics, in case of especially in case of racing cars, that aerodynamics is much important, because it affects the performance of the car. It affects it decides the winner or loser for that competition in F1 race. So it is very important. It is very important for everyone who is interested in automobile or who is interested in cars. So aerodynamics is very important. Yes, it makes the car aesthetically good, but it also makes the car more fuel efficient. It reduces that carbon footprint. It gives a sustainable solution to the world if we efficiently think about that aerodynamics of the car. So the aerodynamics of the automobile is important not only for that comfort, first for the fuel consumption, and fuel consumption is related to the pollution. That fuel consumption is 100% related to pollution. If for some distance, if you want to go 100 miles, and for that 100 miles you spend that 10 liter of fuel for car A, and for car B you are going to use that 12 liter of fuel. So that 12 liter, that extra 2 liter is a load for the society in form of pollution. When you burn the fuel, when you burn that fuel, which is an hydrocarbon, then you are going to increase the pollution level of the earth. And we and all the leader of the world are very much concerned about the pollution and carbon footprint. And another thing, fuel consumption is, in my view, that fuel consumption is one of the most important part, whereas the noise and vibration, control and handling and styling of the car. If you make that car more aerodynamic, then it looks like a very aesthetic, very you can say niche type of thing. And in that case, if you reduce that all that glitches, then you can reduce that noise and vibration of car. And by reducing that noise and vibration, you will provide comfort to the passenger or the rider, and also that controlling and handling, because you are going to reduce that lift and drag for passenger. That passenger might be some racer or some 60 70 years age old man. So everyone needs that, because if you just lose that control or control on the cars, then it will give some very bad taste, or you can say that it will lead to accident. So that aerodynamics in that form is very important. That car aerodynamics, it reduces, if you study that aerodynamics of road vehicles, we as a BTech student studied that fluid mechanics, in which we studied that drag, lift, and other things. At that time, we don't know where it can be used, but now, being an engineer, you can think about that. That part of fluid mechanics can also be used in automobile industry. And for what? The goals of that is to reduce the drag. That reducing the drag will reduce the fuel consumption. Then wind noise, okay, minimizing noise emission and preventing undesired lift forces and other causes which can instable the car at very high speed. So what forces may apply on a car when it is running on the road? The forces. This is the front end of the car. The wind here. This is the wind. Okay. This here. The car is running with the velocity v. In that case, when this wind hits the front panel of the car, this one, then it produces a force. That force is known as thrust. That thrust force will, if the speed is v1, in that case, this thrust force, this opposite force, it will reduce the speed by v minus v1. The effective speed will be this. Might be this is very minimal in quantity, but for sure it will affect the efficiency of the car. Another thing, this is that shape of the car. In that case, the another force is drag, which works against the movement of the car, which reduces the speed, which want to reduce the speed of the car. Another force is lift. At high speed, the car or any body can lift due to that pressure difference. What are the other things? Other things is that downward force, which works against the lifting. Lift is also here due to pressure difference between the outer environment and that car body. Then another one here is drag. So in total, a drag coefficient will be there. That drag coefficient might be 0.3, 0.5, 0.6, anything, XYZ, anything. Lower the drag coefficient, lower will be the resistive force, and it will increase the fuel efficiency of the car. So the aerodynamics is very important for a car. Now, what that drag is, and how many types of drags are there? This is the drag force. This one is the drag force, and this is the structure of a car. That drag force changes its direction and magnitude as according to the structure of the car. Here you can see that they split into two parts. This is known as air splitter or wind splitter, which is mounted at the rear of a car. So aerodynamic drag, this is a force generated by the vehicle movement through the air as it accelerates forward. You can think about that it is something like some air resistance which is going to reduce the velocity of car, and if you want to work against that resistance, then you have to burn more fuel. And in case of that, if you want to reduce that drag, or you want to work against that, then you have to work against that opposing force. And in that case, that will be not very wise solution. So you can see, due to the car shape, the car is moving forward, and this is the air in blue lines. It splits here in two parts, one from the hood of the car, another under the lower section of the car, and then another one is from side. You can see that not only here, the split is also working on another parts, even on this rear view mirror or that door lock or any obstruction that comes in the way of that air. It will distribute that drag force. It will affect the path of drag according to its shape. And in the rear part, what you see, that due to the pressure difference, this is the flow of air, this is the flow of air, and this is the flow of air. So in total, this all movement of airs over and around the car will produce the drag force. And that drag force on a vehicle, maybe that form drag or surface drag or any other kind of drag. First of all, what the form drag is, or what it is also known as the pressure drag. And as the name suggests, this is the form drag. This is caused due to the form of structure, that shape of the cabinet of the vehicle. And this drag force is acts due to the shape of the vehicle as it moves through the air. And that air is the very thin type of fluid. So that air is forced to separate and flow around the wheel, and form drag is influenced by vehicle frontal area. These blue lines are the form drag. These all are the blue lines are form drag. It is due to the shape of the car only. And then the another drag is surface drag or skin friction drag. In case of skin friction drag or frictional drag, you can see here, it depends totally upon the surface finish or surface roughness of the body. If the paint is not that much smooth on that car body, then in that case it will induce that surface drag. It is not due to the shape, it is not due to the form of the structure of the car, but it is due to that the surface roughness of the body of the car. So if anyhow we can reduce that surface roughness, in that case we can reduce this much of surface drag. For sure, this is in very substantial amount, but it is important. It is important. You can see here that in this case, frictional drag, here, if the body is moving, this is the, you can say that car, it is in some wind tunnel, and it is moving in this direction, and the wind is in this direction. Then on this surface, there will be some friction, and due to that friction, what we can see, the separation of layer. You can see that for smooth surface, this is the smaller friction, whereas in case of rough surface, the friction is much and much higher. So it is skin friction drag is very important, and it plays a vital role while designing a racer car or a high-end car. Whereas in case of pressure drag or form drag, like you can see that there is a block which can represent a car body, and from this end the wind is coming, or you can say the car is moving in this way. In that case, when this wind hit this body, it will get deflected. It will get deflected. Some of them will return and will force the other one to deflect from their intended path. And then after that body, the pressure will reduce, and due to that reduction of pressure, the high pressure is there, low pressure is here, then what will happen? The wind will come in from high pressure to low pressure, this one. In that case, this area will, that eddy winds will be there. So the pressure drag is an important part. Another one is interference drag. Interference drag occurs due to the, you can say, discontinuity of the shape of a part, especially in aeroplanes where the wings are there. This is something like that. This is the wing. When pilot want to reduce the speed of that aeroplane while braking or while grounding, then in that case, this wings lift from here to here, this from this place to this place, and due to this one, that here the interference drag will get induced, and this interference drag will reduce the velocity of that plane. And in say a truck or in bus, this force interference drags occurs. Another one is parasitic drag, as the name suggests, parasitic drag. It depends upon the form drag, skin drag, and interference. It is the sum of all these drags, and it represents the total non-lift dependent drag on a vehicle, and can be thought of as the drag that is not directly related to the production of lift or thrust. Another type of drag is base drag and weight drag. Base drag that results from the separation of the fluid flow at the rear of the vehicle, especially when there is a sudden change in the vehicle shape, like this one. This is due to sudden change. Okay. This one, due to sudden change of the shape. Due to sudden change of the shape, that this type of base drag or back pressure drag or rear end drag can be in the picture. Then weight drag. This type of drag is created by the turbulence in the wake of a vehicle, the backside of the vehicle, and this is the energy which lost due to the creation of turbulent eddies and is associated with the vehicle wake area. This is the vehicle wake area. And at that place, this type of drag occurs. Due to the shape of the body, what happens? This is the frontal end of the vehicle and this is the rear end. Due to the shape of the body, the air splits over and around the body. And then here the high pressure will be there, here the low pressure will be there. Due to low pressure, that separated flow will get into the picture, and due to that AD separated flow, AD reason will get into the picture, and this will reduce the the speed of the vehicle. Another one is the lift induced drag or vortex drag. That parasitic drag was not lift induced drag. Here it is the lift induced drag. In this case, the high pressure is there, aerodynamic is there, skin friction is there, low pressure wake is there, but due to this change, slant angle changed. Due to this slant angle changed, like here, the air will flow from this to this. Someone will come from this to this. Due to that sudden change, some drag will get induced. And this occurs when non-streamlined shape is there, especially in van. But in case of high-end car, that part is very much dependent upon the vehicle. Then another one, I can say the total drag. That total drag is the sum of parasitic drag and lift-induced drag. Lift-induced drag, this is due to sudden change of the shape of the body, whereas the parasitic drag is the sum of another drag. Sum of, you can say, that skin drag is there, then form drag will be there, okay. Then in this same case, the wake drag will also be there, and another one. So these all, the sum of these all are parasitic drag, whereas the lift induced drag, this is due to that sudden shape change. If there is a change like this one, then in this case, this sudden change it will induce that lift induced drag. So total drag is the sum of parasitic drag and lift induced drag. Now, the important thing, numerically important thing is drag coefficient. What the drag coefficient is. The drag coefficient for a car should be as minimal as possible. And in fluid dynamics, the drag coefficient is a dimensionless quantity, and which is used to quantify the resistance of an object. In our case, that is the resistance of a car against the air. Okay. This coefficient should be minimum for a car. Okay, that should be 0.003, 0.3. That the minimum drag, if this coefficient is more or less near about 0, then it will give the lesser and lesser resistance. So that drag coefficient, what is that formula for the drag coefficient? This is the ratio. This is the ratio of D. This is the velocity of the car. This is cross-sectional area, and this is that density. So this is the drag coefficient. And if you want to overcome that aerodynamic resistance that due to drag, then you have to work against that. And if you want to work against that, and in that case, that power to overcome the aerodynamic resistance is D cross V. T.V. This is the aerodynamic drag coefficient. So, the summary of this lecture, we learned about various type of drags. Okay, we learned about how it affect the efficiency of a car, not only that speed of car, but also that fuel efficiency, that effort, that noise, and many more things. In our old days, or you can say in early 80s, 90s, there are so many cars like Omni was there, and many more cars. At that time, that aerodynamics was not as important. So, but in our case, that nowadays aerodynamics is important. It increases the fuel efficiency, it reduces the noise, and it gives the comfort to the rider and the passenger. Okay, thank you. We will meet again in next lecture on some another topic.